Look up at the night sky. What do you see? A tapestry of stars, pinpricks of ancient light scattered across the cosmos. For centuries, we defined the universe by these points of light. We built our models, our philosophies, and our understanding of existence around them. We assumed that a planet, a world, required a star, a sun, to be anything more than a cold, dead rock. But what if that assumption is fundamentally, spectacularly wrong? What if the stars we see are just the glittering surface of reality, while a far larger, darker reality lurks in the depths? Welcome to the invisible universe. A universe teeming with trillions of worlds that have no sun to call home. They are the orphans of the cosmos, the exiles of shattered solar systems. They are the rogue planets, the dark nomads. This is not science fiction. It is the latest, most startling revelation from modern astronomy. Deep in the lightless void between galaxies, billions upon billions of these ghost planets are drifting, untethered, alone. And yet, as we are beginning to discover, they may not be the dead, frozen tombs we once imagined. They might be hiding liquid oceans, geothermal heat, and perhaps, just perhaps, life. The revelation is so profound it forces us to confront an existential question. What if everything we know about solar systems is wrong? For decades, these objects were theoretical. We called them interstellar planets or free-floating planets, but we had no way to prove they existed. They are, after all, invisible to our most common tool, the optical telescope. They emit no light of their own. It wasn't until we developed new eyes, capable of seeing the universe in a different way, that the true scale of this hidden population began to emerge. Data from upcoming missions, building on the work of surveys like the Nancy Grace Roman Space Telescope, scheduled for the mid-2020s, points to a staggering conclusion. When we fully map these gravitational ghosts, we will find that rogue planets do not just rival the number of stars in our galaxy, they vastly outnumber them. Look at the Milky Way on a clear night. Estimate the thousands of stars you can see. Now, multiply that by 100. 1,000. The current projections suggest there could be 100,000 rogue planets for every single star in the night sky. We are not just a solar system in a galaxy of stars. We are an island of light in a sea of invisible, wandering worlds. The visible stars are the minority. The ghosts are the majority. How do you create a world without a sun? The process is as violent as it is common. Imagine a young solar system, a chaotic nursery of swirling gas and dust. Several massive planets are forming, competing for material. Their immense gravitational fields tug and pull at one another, creating a complex, ever-changing dance. It's a gravitational skirmish. And in these skirmishes, there are losers. A planet forming in the outer reaches can get a gravitational slingshot, a violent interaction that kicks it with enough force to escape the star's gravity entirely. It is cast out, an exile from its own family, sent to wander the interstellar void forever. For every stable solar system like our own, there may be dozens of these planetary outcasts, born of chaos and condemned to a life of eternal night. So, here is our dark nomad. Ejected from its birthplace, it now drifts through a void where the temperature hovers just a few degrees above absolute zero. The parent star is a distant memory, its light now indistinguishable from any other faint point in the cosmos. Common sense tells us this world should be dead. A frozen, inert tomb, its atmosphere, if it had one, frozen solid on its surface. But common sense fails to account for the power within. Deep in the heart of this exiled world, it is not dead. It is alive. The core of a rocky or gas giant planet is a treasure trove of radioactive isotopes, elements like uranium, thorium, and potassium-40. On Earth, this radioactive decay contributes to the heat that drives our plate tectonics and volcanoes. On a rogue planet, this slow, steady burn becomes its only lifeline. This is the mechanics of survival in total darkness. The radioactive isotopes in the core act like a slow-burning, billion-year-long nuclear battery. As they decay, they release heat. This heat radiates outward, warming the planet from the inside. It's a process that keeps the interior of the world surprisingly warm, even as its surface is exposed to the cold of space. But core heat alone might not be enough. The planet needs a way to hold on to that precious energy. This is where the atmosphere comes in. If the rogue planet is massive enough, a gas giant like Jupiter, it will retain a thick, deep envelope of hydrogen and helium. Hydrogen is a potent greenhouse gas. On a world lit by a star, this would cause runaway heating. Here, it acts as the perfect thermal blanket. This thick atmosphere traps the infrared heat radiating from the core, preventing it from escaping instantly into the vacuum of space. It creates an insulating layer, keeping the temperature much higher than it would be on an airless rock. The surface might be a frozen wasteland, but tens of kilometers down, where the pressure of the atmosphere becomes immense, the temperature could be warm enough for complex chemistry to occur. This leads us to the most tantalizing possibility of all. Many exoplanets we discover are ocean worlds, planets with massive amounts of water. If such a world is ejected into space, its surface water would flash freeze instantly, creating a global shell of ice miles thick. But the heat from the core, trapped by that atmospheric blanket, would prevent the ocean beneath from freezing solid. Imagine it, a world of eternal night. On the surface, a frozen crust of ancient water ice, scarred by impacts and bathed only in starlight. But beneath that silent, frozen shell, there is an ocean. A dark, sunless sea, kept liquid for billions of years by the geothermal heartbeat of the planet's core. It is a habitable shell, a hidden world within a dead world. And where there is liquid water and a source of heat, there is energy. On Earth, in the deepest, darkest parts of our oceans, life thrives without a single ray of sunlight. It clusters around hydrothermal vents, cracks in the ocean floor where volcanic activity spews superheated, mineral-rich water. These vents are oases of life, powered not by photosynthesis, but by chemosynthesis. Bacteria harness the chemical energy from the vent fluids, sulfur, methane, hydrogen, to create organic matter. Tube worms, shrimp, and crabs form complex ecosystems around them, completely independent of the sun. Deep-sea hydrothermal vents on a rogue planet could provide the exact same chemical energy needed for life to begin, a process called abiogenesis. Unlike Earth, where the entire ecosystem is ultimately dependent on sunlight, these hidden biospheres would be alien to us. They would be dark biospheres, life that has never known a sun, never experienced a day. Life that exists in a perpetual state of darkness, fueled only by the geological engine of its own world. Scientists are now actively modeling how such ecosystems could survive, evolving in total isolation for billions of years as their world drifts between the galaxies. The concept is breathtaking. A hidden galaxy of wandering worlds, some potentially harboring life in sunless seas. But if they emit no light, if they are truly invisible, how can we possibly find them? How do you hunt a ghost? You cannot take a picture of a rogue planet, but you can see the effect it has on the space around it. You can track its gravitational shadow. The method is called gravitational microlensing. It relies on a prediction from Einstein's theory of general relativity, mass-warped spacetime. Imagine a distant star. Now, imagine a rogue planet drifting in front of it, from our point of view. The planet is dark, so it doesn't block the star's light like our moon blocks the sun during an eclipse. Instead, its gravity acts like a lens. It warps the fabric of space around it, bending and focusing the light from the background star. For a few hours or a few days, the distant star appears to get brighter. Its light is being focused by the invisible planet's gravity. As the planet moves on, the star fades back to normal. Astronomers don't see the planet. They see a telltale spike in a star's brightness, a perfect, momentary flash that reveals the presence of an otherwise invisible object. By analyzing the shape and duration of that flash, they can determine the planet's mass. This is how we know they are out there. Microlensing surveys have been detecting these events for years, revealing a population of Jupiter-mass worlds adrift in the interstellar void. It's painstaking work, sifting through millions of stars to find those few that momentarily brighten. But it's our only way to count the invisible. And the discoveries are getting stranger. New infrared surveys, capable of detecting the faint thermal glow of a relatively young, still warm planet, have identified something completely unexpected. They've found pairs of Jupiter-mass objects, drifting through space together, with no star in sight. They've been dubbed jumbos, Jupiter-mass binary objects. How do these pairs form? They couldn't have been ejected together from a solar system. The gravitational forces that kick one planet out would almost certainly tear a binary pair apart. It suggests that some of these dark nomads may not have been born in solar systems at all. They may have formed the way stars do, directly from the collapse of a gas cloud. But they were just too small to ignite nuclear fusion. They are failed stars, or something in between. Sub-brown dwarfs. A new class of cosmic object entirely. By mapping the microlensing events and tracking these jumbos, we are beginning to chart the chaotic trajectories of this hidden population. They are not just drifting in straight lines. They are sailing through a complex gravitational landscape, being tugged and pulled by the stars they pass. Their paths are a fossil record of galactic history. Some are on long, looping orbits that will eventually bring them back into the galactic disk. Others are being slingshot out of the galaxy entirely, destined to drift in the intergalactic void between galaxies. By studying their trajectories, we can reconstruct the violent history of planetary migration. We can see the echoes of the gravitational skirmishes that created them, and we can understand how planets are scattered across the cosmos. It also reveals that we are not in an empty neighborhood. Current data suggests our solar system is currently passing through a high-density, dark cluster of these objects. A stream of rogue planets, invisible to our eyes, is flowing past us as we speak. They are here, in our galactic backyard, and we are only just beginning to sense their presence. So, we have established they exist. They are numerous, and they are strange. But what do these dark nomads mean for us? For our future among the stars? For centuries, we have looked at the distances between stars as an insurmountable barrier. The void is empty, we thought, a dead zone to be crossed as quickly as possible. The discovery of rogue planets changes that perspective entirely. Imagine a future where humanity, or whatever comes after us, begins to venture beyond our solar system. A journey to the nearest star, Proxima Centauri, would take thousands of years with our current technology. The void between is a terrifying, empty expanse. But what if it isn't empty? What if it is dotted with way stations? Future deep space missions could use rogue planets as gravitational slingshots. A precisely calculated flyby of a Jupiter-mass nomad could give a spacecraft a massive boost of speed, shaving years off an interstellar journey. They become natural accelerators, placed by gravity across the cosmic ocean. But more than just a gravity assist, what if we could use them? A rogue planet with a thick atmosphere and subsurface oceans is a treasure trove of resources. The water ice on its surface could be mined and broken down into hydrogen and oxygen, rocket fuel. Its internal heat could provide power. It could become a refueling outpost, a safe harbor in the middle of the interstellar desert. This is the concept of island hopping across the cosmic void. Instead of one impossibly long journey, we could make a series of shorter voyages, hopping from one rogue world to the next. They become the archipelago of the dark ocean, a new frontier for exploration and, eventually, settlement. The vast distances that once seemed so empty are now filled with potential. The philosophy of our place in the universe must change. We are not just citizens of a solar system orbiting a single star. We are residents of a galaxy, and our galaxy is teeming with worlds. They are dark, they are cold, but they are there, and they are waiting. The discovery of rogue planets fundamentally rewrites the rulebook of where life can hide. We searched for Earth 2.0, a blue marble in the habitable zone of a sun-like star. And we should continue to search. But we must also look in the dark corners. We must consider the possibility that life is not a child of the light, but a survivor of the dark. That the most common type of world in the universe is a lonely nomad. And on some of those worlds, deep beneath the ice, the fires of life may still burn, waiting for eons in the eternal night, until the universe finally comes to an end.